39 says high temperatures and then number of visitors. So high temperatures be the x-axis, number of visitors be the y-axis. Says create a scatter plot below. Well, I'm going to Desmos for that. I don't know what y'all are doing, but I'm doing Desmos. All right. Would somebody be so kind, because Stirrup can't see, someone read me the high temperatures going across?
Yeah, I got you. 78.
78.
88.
88.
94.
94. Ooh, that's a hot day.
83.
83.
66.
66.
101.
101. That's a real hot day.
92.
92.
88.
88.
90.
90.
80.
And 80. And would you be so kind to read me
The
visitors?
visibility levels or whatever. The 485.
485.
534.
534.
601.
601.
541.
541.
197.
197.
656.
656.
600.
600.
534.
534.
587.
587.
478.
478. Cool. All right. So if you hit the little magnifying plus, it'll give you that. Okay, so let's see if we can answer the questions based on this. So it says create a scatter plot, create the x and y axis, scale as best you can. Heck, I drive vertical, horizontal, just put dots. That kind of look like that. And then it says, what is the explanatory variable? So I'm not that smart, so I have to remember certain cues in life. Explanatory, X has the letter X in it. So that's the x-axis. The x-axis, the explanatory variable would be the high temperatures. And then the response would be the number of visitors. And then it says, is there an association that's positive or negative, and how can you tell? Okay, well, friends, just by looking at that, if I were to make a line of best fit, do you think it would be a positive slope or a negative slope? It's positive. So it has a positive association. And then how can I tell? Well, that means the slope. And then is the association between high temperature and visitors weak, moderate, or strong? And explain. Well, you can look at the data and probably say it's moderately positive, moderate, strong, positive. Okay. But honestly, what I would do is, because Desmos will do it for you, is do y1. We're going to do y equals mx plus b, right? But we have to label x and y, the x1, y1, because they're labels. What was the, rather than using an equal sign, what did I have to use? Squiggly. It's called tilde. So it's the shift of 1. I think it's on the, if you're using your phones for this, I think it's on the alpha page, I think. Okay. And then slope for mx1 and then plus b. And so when we're looking at linear equations, we only look at the r value. The r value is the only one we look at for linear. You would look at the r squared if it's not linear. Anything else? So linear is the only one that keeps r, and r is just basically the visual. Excuse me. R is just how well that correlation is. So my r value looks like it's 0.9373. If you got a 93.73% on a test, are you pretty happy about that? Yeah, I think that's pretty strong. So I'd say it's strong positive correlation to this one. Friends, does that make sense? Did you find the page? And you have a phone? On your phone, go to your apps, load Desmos, D-E-S-M-O-S. And we usually, you get to use your phones on anything in here, which is awesome. All right. Can I move down? Or is there any questions here? Should I stay with that? All right, moving down. All right, so interpret the meaning of each statement. There is a positive association between cholesterol level and heart attack risk. Ew. The higher your risk of heart attack, And it says positive association, so that's positive slope. So that basically means you have a higher risk of heart attack if you have a higher cholesterol level. Ooh, cholesterol. You know, the moment your heart started beating when you were still inside mama, you started flowing cholesterol through your system. But yet it's something that's just bad.
So it is my mom's fault.
Well, it's just genetics. We as people, we haven't figured out how to eat the right stuff, I guess. And then, so B, positive association means it's positive slope. That's why you would have a higher risk of heart attack, the higher cholesterol level. And then there's a weak association between cholesterol level and heart attack risk. Oh. So what would a weak association be? Now, do we know that the weak association did not give us, the weak association means that this R value would be closer to 0, which means our data might be scattered all over the place. Kind of looks like you threw a bunch of mud at the side of the wall and it just splatters. Okay, so if there was a weak association that you found, that just basically means cholesterol has nothing to do with heart attacks. Okay, or it could lead to that. But maybe you didn't choose correctly, or maybe you just chose like people who have perfect diets. I don't know. All right, can I move to the next page? Next page is 130 what?
140.
140? All right.
No, I'm not. 140.
All right. Use the scatter plot below.
130.
Well, things about that, it kind of looks like it has a positive association. I would say it's probably a moderate. You might be able to get away with saying it's weak. Okay, so the explanatory variable on this one, on that page, is explanatory is the eruption time in minutes, and the response is time between eruptions. Okay, so the longer the time you waited for an eruption, the longer your eruption time is going to go. Okay, describe this, the association between Old Faithful eruption time and the time of eruptions. Okay, so the longer eruption, the longer you have to wait for the next one to take place. Okay, y'all been seeing your Old Faithful? Yeah, nothing like pull into Yellowstone and you start reading all the things saying you're in the world's largest volcano. And you're like, I wish I would have known that before I pulled into the volcano. Of course, they tell you on it's too late. It's like, don't worry, if it erupts, everywhere up to the Mississippi is pretty much toast. So, like, uh-oh. So I guess you just enjoy it, and if eruption takes place, then.
Everyone will be like, wow, they died at Old Faithful.
Old Faithful.
And then your family could probably like sue if they didn't just put it on the website.
So, the last question is how well do you think a person can predict the length of time between eruptions from the eruption time? So, being that this is kind of a, being that this is not, this would have an R value probably 0.6, 0.65, somewhere in there, just ballparking it. I don't know exactly. So, if you were 60% sure, 65% sure, are you real sure? No. And there might be times where it's like, man, we're waiting forever. Oh, cool, it's going to be a really big eruption. And all of a sudden, it's like, you know, that's it. Thanks, folks, for coming. See you next time. You're like, I got chipped. All right, last question. Says input the following data into your calculator. Write a sentence describing the association between the variables. You do not need to sketch the scatter plot, so they just want you to plug it in. So X is 467 blah blah, Y is 5574, and then describe the association. Okay, so the association could mean a couple things. Let me get rid of this data real quick. La ta ta ta. All right. Will someone read me X going across, please?
Yes, I can.
All right, Gabe.
4, 6, 7,
Uh-huh.
4, 5, 2, 8, 7, 5.
8, 7, 5. And the Y value?
5, 5, 7.
5, 5, 7.
4, 5, 8.
4, 5, 8.
3, 6, 2.
3, 6, 2. All right. You hit the little plus button. Ooh.
I don't understand why it's a negative though. It
Well,
looks like it should be positive.
well, I agree. So that is a great question. Now, here's the hard thing. If I said, hey, do this by hand, I'm going to get answers all over the place. I'm going to get some people to do positive, some people to do negative, some people just put a big question mark. I would trust the technology. The R value, oh my gosh, the R value is negative, and it's negative 28.57. That's like getting a 28.6% on a test. Pretty happy about that? No, I hope not. Yeah, this is a weak negative correlation. And you know, and if you want, if this was something that you truly felt that there was some sort of relationship between X and Y, I mean, we have basically 10 pieces of data that we plugged in. If you truly think that this is something more, get more data. Get more data that fits with it, okay? But yeah, this is what the calculator is doing, figuring out that R value and then determining if it's a positive or negative. So basically the calculator does an iteration. It thinks it has a line. What this R value really truly means is this. This R value is the average distance that the points are away from the line. So remember yesterday I showed you the residuals? So basically, if I did my residual plot, which are the plots down below, what they basically do is if you were to add up all of these, keeping the positive and negatives as positive and negatives, and divide by the number, that's going to give you your R value. Okay? So it's the average distance. So like this distance here is this far above the x-axis. This little tiny distance here is that far below the y-axis or x-axis. This distance here is that distance, so on and so forth. So it's the average distance away from the line of best fit that they put in place. And I will tell you, friends, doing a dot plot or a scatter plot by hand and figuring out the residual based on your line of best fit, it is the most tedious, ugliest thing in the world. Let's give Decimal some an applause. I mean, hey, they're taking care of us. All right, so that was that. Did I answer all the appropriate questions on the homework? Do you feel comfortable with it? Good. All right. So let's go to 2-2. 2-2. All right. Hey, what page is this on? 2-2? Page 33. Find 33 in your books, please. Says in statistics, correlation is simply a number that is the measure of both the strength and the direction. Direction is positive or negative. Strength is, if it's positive, closer to +1. If it's negative, closer to -1. Okay? Okay, how far you things are. In the previous section, we observed that direction estimated the strength from the scatter plot, but correlation quantifies the relationship in a way that takes some of the judgment away. Okay, again, that R value is something to look at. And again, that residuals plot really means something. What did I say about the residual plot, which are the red dots? What did I say about that yesterday with residual? Do you want it to be a random scattering of dots, or do you want some sort of fantastic pattern?
You know pattern?
Patterns on residuals are the worst thing in the world. It's
Never mind.
no patterns. I know that we want patterns because patterns are good. Like, dude, math is all about patterns. Patterns as far as residuals go, patterns, let me explain this. Patterns with your dots is really good. patterns with the residual, the average distance away from the line of best fit is really bad. And that's something I can't emphasize enough, that if somebody presents you material and they show you the residual plot based on the material, if you see a pattern on it, you got to raise your hand and say, hey, look, Stirrup said, mm-mm. And they're like, who's this Stirrup you talk about? It's like, he's the rhinestone cowboy. No. So, all right. So it is important to emphasize that correlation is one of the most poorly understood statistical concepts. Okay. And then correlation is designed the variable R. The correlation is always numbered between -1 and +1. These are all things that we have talked about. The closer you are to 0, the more scattered your data points are that you graphed. Okay? If the correlation is positive, positive association. If it's negative, negative linear association. And the extremes of +1 and -1, the correlation identifies a perfect rising or falling in the relationship. Okay. So, are we good so far? Can I move down? You guys don't want to do that one? You following the madness of Stirrup for the day?
Point out from this one,
Where are we at?
the correlation is a negative number.
Number. We got numbers now. All right.
It is number.
All right. All right. Add the extremes correlation. We got that. Get the correlation R from your calculator or computer. Okay, so again, that R value. Again, ignore R squared for now. R squared is not used. R squared is basically the two-dimensional look, the distance from the X and the distance from the Y axis. Don't worry about the R squared value. Just worry about the R as far as straight lines go, or line of best fit. So they tell you have a R value on the one on the left is -1 because it's a perfect negative sloped line. And these are, R equals -0.7, R equals -0.4, R equals 0 is just a spattering. R equals +0.3, R equals +0.8, R equals +0.1, or +1. That's your straight line below. The correlation coefficient of 0 can play out in a number of ways. The graphics look at scatter plots, observe in ways that scatter plot might still have distinct patterns. So if you had a scatter plot that you had plotted and it looks like it's forming a parabola, then you don't do a line of best fit. You do a quadratic of best fit. If it looks like it's a third-degree polynomial where it's got, drops to the left, rises to the right, and has a wiggle in the middle. I don't know, did you cover an algebra 2? Bounce, wiggle, cross?
Oh, yes.
Yes, that starts talking about this stuff. Yeah.
It bounces off the X.
Yep, bounces off the x-axis. Wiggles, if it has a little dance it does.
Then it crosses the curve.
And if it crosses, you have a single binomial. If it bounces, your binomial is an even amount of binomials, like x plus 2 quantity to the fourth, and they bounce. And then if it wiggles, if you have x minus 3 parentheses raised to the third, fifth, or whatever odd number. All right. Oh my goodness. Look at all of these wonderful looking.
They're so small. Oh,
Okay.
God.
So notice the very bottom. You got like a W, that's a 0. You got this square or diamond or smiley face, or I don't even know what that is. A parabola open up or down, which would be called a hyperbola if you ever took that. Circle, quadrants or 4 dots, those are all 0 correlation. Okay? So it should be noted that the real world data are often messy and convoluted. Scatter plots that form such clear, distinct shapes don't occur. But in an exercise, the understanding of correlation and aspects of the scatter plot, they should measure the bottom row of the displays shows nicely that 0 correlation doesn't always emerge from a random scattering of points. So guys, if you plot data and it looks like any of that very bottom row, let me know what you plotted. I want to see it. I want to see what you did. All right. So the correlation is the number, has no units of measure. Again, correlation as close to positive 1 or as close to negative 1 as you can get, depending upon if the slope of the line is positive versus negative. That's really what you want to get. Correlation doesn't have any unit meters. Scatter plot of temperature to speed. You can get some correlation if you compare degrees Fahrenheit to miles per hour as you would degrees Celsius to minutes per second. Okay, that's the last thing we're talking about. Guys, my friends, you all have probably taken chemistry. And you all sit there and have probably the same wondering that I had when I was a kid. What's this Celsius stuff? Like, dude, Fahrenheit. Like, yeah, it's 23 Celsius. You're like, that means nothing to me. Actually, when I was in school, Celsius was called centigrade.
Ew, really?
Kid you not, yeah. And then they changed it to Celsius for some Latin root problem. And then you got into the whole thing about Kelvin. Oh, Kelvin's absolute value.
Kelvin,
Yeah,
Kelvin makes sense if you're talking about like the sun or something.
You want to know what zero? Does your chemistry teachers ever tell you what happens at 0 Kelvin?
Yeah.
No,
Yeah.
everything's stopped.
Yeah, all molecular activity stops. Now,
You can freeze time here.
if your nucleus is positive and your electrons are negative, they are being attracted to each other, right? And because the electrons are orbiting at a speed going around the nucleus, they are still attracted to the nucleus, but because of their centripetal force, they are staying out there at that. If you got to absolute 0, in theory, though they come very close to absolute 0, they haven't gotten there. If you got something that had absence of all temperature, the electrons would come crashing into the nucleus, and that would be bad. And then things go boom. Because you have positive and negative going, hey, what's up? Boom! You don't want to deal with that. Now, they've gotten down pretty cold on the Kelvin scale. But,
Please, how can you-
oh, yeah, it's close. It's close. Huh?
how can you not know temperature?
Well, that's the thing. If you have an electron that has movement to it, there's got to be some sort of temperature that is existing. Huh?
What is the max temperature? Because I know, like, obviously it could go on, but I feel like there's a point at which there's so much energy in the system
That the electrons are so far away.
they would
I
just
mean, the
spray
hotter it
apart.
gets, the further away the electron orbit takes place.
Yeah.
So if you got so much energy that those electrons are out here, I don't know what.
I feel like they would just break off.
I don't know. I don't want to deal with that. I mean, I've made that mistake where you go and pour the hot water into the colander with the pasta and get a little hot water and it hurts. I don't want anything hotter than that.
So,
I'll test it later.
I will tell you, as a kid in Arizona, my feet will never be the same. We used to see who could stand on the street the longest barefoot. Now, mind you, when I lived in Arizona, there was 2 days in the 90s that made 122 for temperature, and they shut the airport down from 9 o'clock in the morning till 9 o'clock at night. Healthcare. Yeah.
oh, we could have fun.
Yeah, I know. I could. All right. So, hey, what page is this? This is in your book. One we work. 141, page 141, 142. So take a look at those. It talks about R values. Yeah, 141, 142. I think you guys can handle that. Have some fun with it. We'll go over. Today's Thursday, right? I didn't have a quiz planned for tomorrow. Oh, and that does make a point. I did get your test graded, and some of you already asked, hey, can I come in and get extra points? Yes, you can. Guys, I'm off 4th, 5th, and 6th period, so if you come in, I'll give you half your points back if you let me go over your test or quiz. Cool? But there's also times where it's you like come in going, hey, Stirrup, I read this question this way, and this is what I think the answer is. Okay, I'll give you that point back. So you never know. It's always good to argue with your teacher, get points back.
We love arguments.
Oh,